So, greetings to everyone. Welcome to Arba Academy classes. So, this video is mainly about to give the solutions for the reinforcement concrete design problems. So, without wasting any time, let us go into the first episode of this solutions channel. So, with this, the first problem that we are going to solve is the RCC mix design. So how we are going to do the mix design, what are the things that needs to be considered before we go into the reinforced concrete design problems. So just a brief, what exactly is a mix design? Mix design is a process of selecting the appropriate proportions of materials. So the basic materials used in the concrete are cementitious materials from cement and fly ash and many other cementitious materials are there, along with water and aggregates. So in aggregates also the fine aggregates and coarse aggregates also. So why this mixed design is to be done is exactly the correct question to be asked. This is mainly done because we need the concrete with the desired strength, workability, and the durability. So strength part, yes, it's a part of serviceability as well as workability. Workability means the ability to make the concrete workable. Okay. So for example, during pouring and placing of concrete or during pumping of concrete, the concrete should be in a workable situation so that more easily the concrete can be poured. And then durability. So durability aspects, there are multiple aspects with respect to RC, reinforced concrete. So all these terms definitely need to be considered while formatting the mixed design. So in India, we follow IS 10262. That's the Indian standard for the RC design mixed design guidelines. So with respect to IS 10262, so let us move into the steps in the mixed design. So the first step will be the select the target strength required for the concrete. Next is we need to select the appropriate water cement ratio. Followed by we need to find the aggregate air content. And after that, the water content for the concrete followed by the cement content for the concrete. And after that, we need to know how much aggregates we are going to use, what type of aggregate, how the condition of aggregates to be used. So everything is to be considered. And then design trial mixes. And after that, we need to conduct tests. So for tests, you need to have during cubes. So the cubes to be casted and they need to be cured for 28 days and then they need to be tested for the compression test. So once the compression test is done, so based on that, whether we achieved the appropriate strength of the concrete or not, we need to verify. So once it is done, the final thing is we need to make some adjustments based on the test results, whether if they are giving the appropriate values that we require or it satisfies our values, then it is okay. Otherwise, we can make some minor changes. That part comes as the adjustment. So we now know the steps, and we also need some of the data in order uh, for the mix design to be calculated. So we'll now see what are all the data that we require. So the first and foremost data is grade designation. Which grade are we going to start? Whether are we going to start from M5, M10, M15, M20, M25, and there are now design mixes are there when reaching up to M1 also based on requirement and on special purposes. Right, so that's a grade designation step. Followed by the type of cement. The type of cement is majorly, there are PPC cements are there, Portland, Pozzolano cements, and ordinary Portland cements, so OPC, and the respective grades of cements are also varying. So depend on grades of the cement, the strength of cement also varies. So we need to have a fixation on the what type of cement that we are going to. Followed by the maximum nominal size of the aggregate. So particularly the coarse aggregate. So whether it is 22 mm, 20 mm, 25 mm, so which is the maximum nominal size, because in the volume of the concrete, the major big chunks of materials are these coarse aggregates only, and then followed by the minimum cement content that we need to consider for the mixed design, how much kilogram of cement that we need to have per mq, and then the maximum water cement ratio, because water cement ratio is the uh, ultimate content for deciding the cement content. And then workability of the concrete, whether it needs to be pumpable or whether it is self-compacting concrete. So all these things that are need to be taken into consideration, because for example, if it is self-compacting concrete SCC, then the volume of coarse aggregate will be much more reduced and the volume of fine aggregate will be increased in order for the more workable and self-compacting condition to occur in the concrete. And then followed by the exposure conditions. So these exposure conditions vary from normal, medium, until severe, and very severe conditions are also there. Majorly the severe, the conditions of exposure determines with respect to the corrosion, majorly, and the intrusion of chlorine and sulfate compounds into the concrete um, layers. So that's what the exposure content is majorly about. And the more the exposure, the more we may need to give the minimum content of cement, and vice versa, right? Followed by the maximum temperature of the concrete at the time of placing. So there are multiple locations having different temperatures in the world. So at each location also the concrete is being poured. So depending on what exactly the placement temperature should also be taken into consideration. And the method of transportation, placing, as well as for pumping. And then the early age strength requirements. For example, initial setting time in some situations that needs to be attained in a very few moments. So that part of special requirement purpose is also there. So if required, that part also to be taken into consideration, followed by the type of aggregate we're going to use and the maximum cement content. So there is a limit for the minimum cement content as well as the maximum cement content, because the more cement you add it, the mix will not have, or the mix will not attain its respective strength that we design. And the choice, type, and condition of use of aggregates, and the admixtures. So the choice, the type, and condition of use of admixtures. The admixtures play a very important role, because from superplasticizers, and there are multiple agents that can either act as a catalyst or either that can influence the mix design. Either it can influence the strength or it can influence the water cement ratio or the water quantity. So there are various kinds of aggregates, various kinds of admixtures in which the respective admixture can play a different role. So how much you're going to do, you're going to use, and what exactly the admixture that you are going to choose, and how you are going to include it in the mix design, at which stage or which part of the process you are going to mix it with the volume of the concrete. So everything that needs to be done over here. Okay. So with that, what we are going to do is we are going to solve a problem. Okay. So the problem is already put here, as you can see in this page. So we're going to have a mixed design for M30 concrete with the respective details that are provided. So cement, we are going to adopt OPC 43 grade. This is also conforming to IS 8112, and all the other values are also being taken, right? So this mixed design, so this is mainly followed with respect to Indian standards. So based on there are no restrictions that you can do or you can adopt any mixed design in the world, and you can arrive at one particular value which can be used for the project. So there is no restriction that you need to only use IS code or IS mixed design guidelines only in India. No, it is not. So if the mixed design value is approved by the client, then there is no restriction at all. Any international guidelines or any mixed design guidelines can be used, either it is of ACI, either Eurocode or British standards or Australian standards, or even the Middle Eastern standards, even IS standards, Japan standards, Chinese standards, anything you can adopt for finding out, right? So, in order for the data, as part of data is concerned, there are some values that need to be incorporated in the mixed design after testing of some of the materials, like the specific gravity of cement, fine aggregate, and coarse aggregate, and the admixtures. So those are all the testings first needs to be done. Then only those values will be obtained. So those testing will be done in separate civil engineering laboratories, and then there is these results to be incurred. And also the water absorption ratios of these aggregates also to be incurred, right? Okay, so we are going to have solution steps. So majorly 6 to 7 steps are there. So let us start with step 1. We're going to find out what is the target strength. So, as per class 3.2 of IS 10262, the target strength is given with respect to the calculation along with standard deviation value. The FCK dash is equal to FCK plus 1.65 S. So this S stands for the standard deviation value for M30 mix. So this is where the considered mixed design value plays a role. So if you're going to consider for M25, then the S value varies. If you're going to consider for M30 or and above, the S value varies. So S here is 5 Newton per mm square as per table 8 of IS 456. So now the target mix strength is this one. FCK dash becomes 38.25. So this 38.25 is our target strength for all our cubes that are being tested after a curing of 28 days. So more than 96% of the cubes should pass or should be nearby this particular value or greater than this value. Then only we can say it as this design mix is passed. Otherwise, we may need to revise the design mix again. So this is just a thumb rule. You can verify this value varies from project to project. So it definitely decides upon the client how the value is going to be taken in. So followed by the step 2 is your determination of water cement ratio. So the minimum cement content is already we have taken it as a data. So it is 300 kg per m cube, but the maximum water content water cement ratio for this minimum cement content is 0.5, which is taken from table 5 of IS 456. So we are going to adopt a water cement ratio which is less than 0.5. So we are going to take 0.45 as a value. So step 3, your water content determination. So as we have fixed our water cement ratio as 0.45, so we also have determined the maximum nominal coarse aggregate as 20 mm. So the maximum water content as per table 2 of IS 10262 is 186 kg. That corresponds to a slump value of 25 to 50 mm. So if we consider for 75 mm slump, then what you need to do is there need to be an increase of 3% in the water content. So 186 plus 3% of 186 is 191.58 kg. And if we are adopting superplasticizers in our mixed design, then there can be a reduction of 10% in that particular. So the final water content becomes 153.2. Based on the power or the character of the superplasticizers, from 10% to 30% also, the water content can be reduced. So here we have adopted 20% reduction. So the final water content is 153.2 kg. So step 4 is your cement content determination. So water cement ratio considered as 0.45. We have considered in the last step the water content as 153.2 kg per m3. So the cement content is, we need to just divide the water content by water cement ratio. So that gives 340.4 kg per m3, while the minimum cement content is 300 kg per m3 and the maximum cement content is 450 kg per m3. So whatever the value that we have determined right now, it is definitely between the range from 300 to 450. So the value of cement is okay for us. Proceed. For step 5, the aggregates going to find out. Okay, so from table 3 of IS 10262, the volume of coarse aggregate for corresponding 20 mm size, the water cement ratio of 0.5 is 60%. Okay. So there is a rule on IS 10262 is that for every increase or decrease of water content by 5%, the volume of coarse aggregate to be decreased or increased by 1% respectively. Or in other words, vice versa. If your water content is increasing, then your volume of coarse aggregate should decrease. If your water content is decreasing, then your volume of coarse aggregate should increase. So as the considered water cement ratio is 0.45 and the volume of coarse aggregate given is 60% for water cement ratio of 0.5, there is a 5% reduction in the water cement ratio. As the water cement ratio is reduced for 5%, so there will be an increase of 1% in the volume of coarse aggregate. So the final volume of coarse aggregate becomes 60 plus 1%, so it becomes 61%. So for pumpable concrete, as you know, this concrete to be pumped to respective levels of height, the volume of coarse aggregate can still be reduced another 10%. So the final volume of coarse aggregate becomes 61% into 0.9, so that becomes 0.55% or 0.55. So if your coarse aggregate is 0.55, then the volume of fine aggregate will be 1 minus 0.55 because the other half is occupied by fine aggregate. Okay. So 45% will be occupied by fine aggregate and 55% is occupied by coarse aggregate. So now that we know the ratio of the occupancy of these respective aggregates, so we need to determine the kilogram weight per m cube of concrete. So we know the volume of concrete is 1 m cube. We have to calculate the volume of cement, so which is equal to the mass of the cement divided by specific gravity of cement. So we know both these values now as we calculated from the respective steps, and the specific gravity is given data. So with that, we now know the volume of cement that we are going to use. And then we need to find out volume of water. So simple, mass by gravity, both of them with respect to water to be used, and the volume also can be determined for water. And then the volume of chemical admixture also to be determined. So for which there is a rule stating that 1% by mass of cementitious materials to be used. So, as we have the mass of cementitious materials is 340.4, the mass of admixture will be 1% of it, which is 3.4 kg. And the specific gravity of admixture, already it's a given data, 1.15. So, we now know the volume of cement, now know the volume of and the volume of admixture. So, the next step is the total volume of aggregate we are going to calculate. So the total volume of aggregate will be 1 minus, overall is 1 minus the volume of cement, volume of admixture, and volume of water. So that gives you the overall volume of aggregates. So in that aggregates, 55% is occupied by coarse aggregate and 45% is occupied by fine aggregate. So we are going to find out the mass of coarse aggregate first. So based on 0.736, that's the volume into 55% into specific gravity of coarse aggregate. So that will give you the mass of the coarse aggregate, coming around 1085 kg. And likewise, you need to apply for fine aggregate as well, the total volume of aggregate into specific gravity of fine aggregate. The mass of the fine aggregate, you're going to find out similarly with respect to coarse aggregate, the total volume of aggregate into specific gravity of fine aggregate, that gives you somewhere around 878 kg. So the final mixed proportion is given here. So the cement is to water, fine aggregate, coarse aggregates, chemical admixtures, water content, all are with respect to kg per m cube except the water content value. Water content is just the ratio, 0.45. All others are kg per m cube. That's a unit for each of these first 5 elements. And if we plot a ratio for cement is to fine aggregate is to coarse aggregate, we are getting around 1 is to 2.57 is to 3.18. So this is not the final value of the mixed design, because once this mixed design is arrived, we need to put up the cubes. They need to be casted. The cubes need to be cured. Then they needs to be compression tested. And based on the compression test, the final adjustments in the mixed design, if it is required, that needs to be done. And then only the final mix ratio can be confirmed. So this is how the mixed design is created. So hope from this video you now know how to calculate the mixed design as per Indian standard 1062. So thank you so much for your time and patiently listening to the entire lecture. So thank you so much. Bye. If you like this video, kindly subscribe to the channel, like, share, and give comments on the video. Thank you so much.